Hi, I am Vivi. In the second part of the video for our decision support class, you can test what you have learned by guessing the right approach or test according to a question given. I will include the test we review on my other video. Descriptive statistics, correlation, one sample t-test, one sample z-test, two sample t-test, two sample z-test, one-way ANOVA, two-way ANOVA or factorial ANOVA, simple linear regression, multilinear regression, and logistic regression. Now let me introduce you to the scenario. We have the data from a flower shop. Their system records the transaction number, date, year, number of flowers purchased, reason for the purchase, wedding, graduation, or birthdays, colors of the flower, yellow, white, or red, number of cards purchased with the flowers, type of payment, money or card, and money collected from the purchase. Ready? Let's begin. From the last 20 purchases, are the yellow flowers 70% of the purchases? One sample t-test for proportion. It is a t-test because our sample is the last 20 purchases. A sample is smaller than 30. And it is just one sample instead of two samples because we are not comparing two variables. We are comparing one, the revenue, with a given value, which in this case is a proportion. The right approach would be to filter the data to get just the information from the last 20 purchases and then run the t-test. Do the money collected differs depending on the color of the flower? What flowers make more revenue? One-way ANOVA. It is one way because we are only using one dependent variable, the money collected, and one independent, the color of the flower. It could be two sample test if it wasn't because we are including at least three groups in our independent variable. We want to get information depending on the three colors available, yellow, white, and red. Do people buy more cards when they buy more flowers? Correlation. We are testing if there is correlation between two variables, the number of cards and the number of flowers. Do the proportion of white flowers is equal to the proportion of wedding events? Two sample z-test for proportion. It is a z-test because our sample are all the customers the shop has had, more than 30 for sure. It is two sample because we are using two columns or data, two variables, the color of the flowers and the events. And it is proportion because we are comparing proportions. Do the number of cards is reliant upon the reason of the purchase and the number of flowers purchased? Two-way or factorial ANOVA. It is a two-way ANOVA because we are using two independent variables, the reason of purchase and the number of flowers, and one independent variable, the number of cards. Do usually the customers buy around 12 flowers in their purchases? One sample z-test for mean. It is a z-test because our sample are all the customers the shop has had, more than 30. It is one sample because we are using one variable from the data, the number of flowers. And it is mean because we are comparing our data with the value given. Is the next purchase going to be paid with money instead of card? Logistic regression. The answer for this question is a yes or a no. It is also asking you for the odds of an event to occur. What is the favorite flower color for the customers at the shop? Descriptive statistics. We use the mode over the colors of a flower column. Do the revenue increases if people buy more flowers and more cards? How much? Multilinear regression. The key word on the question is how much. It is asking us if it's possible to make a prediction, so we know it's regression. It uses three variables, our dependent variable, that is the money collected, and two independent, that are the number of flowers and the number of cards. It could be confusing since the answer for the question seems to be a yes or a no, but it actually isn't. The only way to assume if the revenue increases is to see how much these three variables are related. The answer to this question is actually a number. We want to see how much the revenue increases if the number of flowers and cards increase as well. For the first 10 clients the store ever had, did the customers decide to buy around 2 cards per purchase? One sample t-test for me. It is a t-test because our sample are the first 10 clients. A sample is smaller than 30. And it is just one sample instead of two samples because we are not comparing two variables. We are comparing one, the number of cards, with the value given, 2 cards. The right approach would be to filter the data to get just the information from the first 10 clients and then run the t-test. Is the money collected from white flowers equal to the money collected from red flowers? Two sample z-test for me. It is a z-test because our sample are all the customers the shop has had, more than 30. It is two sample because we are using two columns of data, two variables, or let's call it two samples, the color of the flowers and the money collected. And it's mean because we are comparing two means, the means from the money collected when the flowers are white and the mean from the money collected when the flowers are red. Can we assume that people buy more cards if they buy more flowers? Simple linear regression. The keyword on the question is assume. It is asking us if it's possible to make a prediction, so we know it's regression. It uses only two variables, number of cards and number of flowers, so we know it's simple. Now, it could be confusing since the answer for the question seems to be a yes or a no, but this is not the answer. The only way to assume if the people buy more cards or no is to see how much these two variables are related. The answer to this question is a number. We want to see how many cards people will buy according to the number of flowers. 50% of the events for the customers to buy flowers are just weddings. One sample z-test for proportion. It is a z-test because our sample are all the customers the shop has had, more than 30. It is one sample because we are using one variable from the data, the events, the reason. And it is proportion because we are comparing our data with a proportion given, 50%. Thank you so much.